Hello everyone, welcome back to the channel. I am the EE Guru, and today we'll be talking about Kirchhoff's current law. So Kirchhoff's current law states that the sum of current entering a node is equal to the sum of current leaving the node. So on the bottom right here is the mathematical representation of Kirchhoff's current law. It says that the sum of current entering a node is equal to the sum of current leaving the node. If you guys are confused about this symbol right here, this symbol is called sigma, and it's a symbol that indicates summation. So this image right here does a great job of illustrating Kirchhoff's current law. As you can see, we have a node in the middle right here. And then we have current flowing into the node and also current flowing out of the node. So the arrows that are pointing into the node is the current that is flowing into the node. And the arrows that is pointing out of the node is the current that is flowing out of the node. And as you can see that I1, I2, and I3 are flowing into the node. And the summation of I1, I2, and I3 is equal to the summation of I5 and I4. And this is Kirchhoff's current law. Another important point to mention is the conservation of current at a node. So you can imagine that we have a node right here. And we have, let's say, I1 flowing into this node. And let's say we have I2 flowing out of the node. Because current is conserved at a node, if we say that I1 is equal to 5 amps, then I2 must also equal to 5 amps. I2 must equal 5 amps also. So what is the difference between I1 and I2? What is the difference between current flowing into the node and current flowing out of the node? The difference is 0, because 5 amps subtracted by 5 amp is equal to 0. And this is what this equation right here is describing. Basically, the current that are flowing into the node, I1 plus I2 plus I3, subtracted by the current that is flowing out of the node, I4 and I5, is equal to 0. That's the conservation of current at a node. And the important thing you should note about Kirchhoff's current law is that it allows us to predict mathematically the current that is flowing out of the node given the current that is flowing into the node. So previously what we did right here, we said the current that was flowing into the node was 5 amps. So we were able to predict I2 because we know that the current that is flowing into the node is equal to the current that is flowing out of the node. So if I1 is equal to 5 amps, I2 must also equal 5 amps. And vice versa, if we knew the value for I2, we can predict the value for I1. Or if we knew the value for the current flowing out of the node, we can predict the value for current flowing into the node. So that's the video. Don't forget to like and subscribe. Next video, we'll be going over example problems. So stay tuned.